Okay, so today we're going to continue talking about plate tectonics. As you know, the Earth's crust consists of several plates. On this map, the green lines show you the edges of the tectonic plates. These plates are always moving, of course, and exciting things happen as a result. The lines you see here on the map where the tectonic plates come together, those are the earthquake zones. These areas here, in orange and red, are places where earthquakes occur most often. Furthermore, the biggest, most dangerous earthquakes happen in these zones. Now, when earthquakes occur, there are three different things that might be happening along the boundaries, the places where the Earth's plates meet. For your notes, why don't you set up a chart like this one, with 4 columns and 3 rows? It will be helpful to you later. In the left-hand column, write boundary type, movement, and results. Notice that I'll be talking about 3 kinds of boundaries, about how each boundary type is moving, and finally about the result of that movement. Okay, as I mentioned, there are 3 main boundary types. The first kind are called convergent boundaries. There, plates come together. This pushing together can cause mountains to form. One plate can also move under another at a convergent boundary. That makes the mountains on the top plate rise even higher. In fact, the highest mountains on Earth, the Himalayas, shown here in the photo, are the result of a convergent boundary. The second type of boundary is called divergent. At a divergent boundary, the plates move apart. As they move away from each other, a body of water can form between them. A good example of this is the Arabian Gulf region, where the Arabian plate and the Eurasian plate moved apart to form the Arabian Gulf and the Gulf of Oman. More recently, the 2 plates have become convergent again, forming mountains. You can see those at the top of the photo. You don't have to worry about the Arabian Gulf disappearing anytime soon, though, because these changes take place over millions of years. Okay, the third and final type of boundary is called a transform boundary. There, the plates are moving past each other. To give you an example, along the San Andreas Fault in California and northern Mexico, one plate is moving north, while the other plate is moving south. The plates don't move smoothly, however. The movement actually only happens occasionally, when the plates move in small or large jumps. And when the plates make a big jump, the Earth shakes, and we have a major earthquake. Now, let's take a look at the effects of some recent earthquakes, how they affected people in the world's earthquake zones. In Chile, in 2010, there was a major earthquake. This picture shows an example of buildings that are constructed in the right way for earthquake zones, with strong reinforced walls, especially if the walls are made of concrete. I know it looks like these buildings were badly damaged in the earthquake, but the buildings actually stayed together in one piece, and that's what you want. Everyone who lived in these buildings probably survived. Another way to build the right kind of buildings for earthquake zones might mean houses with roofs and walls made of lightweight materials that will not collapse, or at least they won't kill you if they do. In this photo from the Philippines in 2017, you can see damage to the road, but these houses, with lightweight walls and roofs, are still standing, and the people who live there are safe. In contrast, living in a part of the world where the buildings don't have these features can be quite dangerous. This picture was taken after the 2015 earthquake in Nepal, where many houses collapsed. About 9,000 people died in that earthquake. So let's look again at our world map. The world's next big earthquake will probably be in one of these areas in yellow, orange, or red. And the number of people who survive the next big earthquake? It depends a lot on the kind of buildings they live in.